Okay. All right. So using a new document camera, I think it works okay. I think this one doesn't have a microphone in it. So when I turn away from my computer, sometimes it's a little bit quiet. So I will try to speak loudly at this thing. Okay. So not yesterday. We did a quiz yesterday. Monday, we did slope. We did rise over run and the change. So it's really nice when you have the pictures. Really easy to do. So what is the change between point A and point B in the Y? So we said that M was rise over run, or it could be the change in Y over the change in X. So we talked about that before. Those are things that we did way back in chapter 3. So this one, looking at this pretty picture, what's the change in Y? How far do we go up? Assuming that this is 2, that's 4, that's 6. So how far did we go up? So if A was at point, oh, look at that. So that one's not nice, is it? Are these right on the lines? No. So all of a sudden this is a lot, like we can't use that rise over run, that pretty picture that we've always used. And when it doesn't look nice or it has decimals in it, which are possible when we're graphing, we can go to a formula. No. Because life doesn't always happen on the lines, I'm afraid. This is your formula for slope. So M is equal to y2 minus y1 over x2 minus, well, let's try that again. I messed up, over x1. Okay. And that's not a big surprise. Y is on the top, X is on the bottom. We've talked lots about that. But what you do need to be careful with this one is that this is a coordinate pair stacked on top of each other. And this is a coordinate pair stacked on top of each other. So your coordinate pairs aren't side by side when we put them into the formula. They're stacked on top of each other.
Why do you need this formula again?
So if you look at point A, does point A fall on a line?
No.
Right? So what would you say that coordinate pair is?
Oh.
Right? So it's not nice. Like it's not on like the nice spots on the graph, right? So this picture makes it really hard for us to give an accurate one. If you can do rise over run, if it's right on the corners of those things and it's really nice, simple, use rise over run. Use the change in Y over the change in X. It's just when we get to here where you have a picture that doesn't work, or I don't give you a picture at all. So you don't need to graph it. So this is nice. Using this formula is nice because you don't need to graph the points to see the rise over run. You can do it straight from the formula, which is kind of nice too. So in this example, we are going to use the formula. So what I would suggest to you, it doesn't matter which is your first set and which is your second set, but you need to be consistent. So as we're learning this, I would label them. You have to wait till I get my hand out of the way, bud. So how are you going to solve that problem?
You're going to move.
Okay, Jonah says you're either going to move, which is a valid option, or what are you going to do?
Ask them if they please close.
There you go. See? See? Nami's still looking after people. I appreciate it. It's a tough spot. We should have a disclaimer on that desk that you are the keeper of the window. All right. True story? Yeah, but then they'd be hanging over Nami. It would be bad.
Now it's too dark.
You'll be fine.
Life is awesome.
Does that help?
Yes.
There you go. Look at that. There's a light.
That's so awesome.
Okay. So the first thing I'm going to do is I'm going to label my first coordinate pair, and we know that in a coordinate pair the x comes first and the y comes second, right? Everybody knows that. These are not exponents. They're called subscripts. It's just a fancy name for like keeping the order of them. It's like saying Summer student 1, Jonah's student 2, Snae's student 3.
I want to be number 1.
Sorry, Summer was. She's number 1. So it's just a way to like keep your stuff organized when they're similar things. So now we're going to fill in our formula. So our formula is y2 minus y1 over x2 minus x1. So nice easy formula. Y is from y, so everything on the top is y, everything on the bottom is x. Maybe I will. Okay, so what is my value for y2? What's my second y value? I've got it labeled here. It's 1. So we're going to substitute that into the equation. And we are subtracting the first y value from it, which is negative 3. That's our first y value. So I'm going to use some brackets here. Negative 3. What's my second x value? 2. And what is my first y value? Negative 5. So coordinate pairs should be stacked on top of each other. So these match. And they're in the reverse order because y's are on top. Okay. When we're subtracting a negative number, what happens there? It becomes an add. So my slope is 4 over 7. Easy peasy. I know. It's hard sometimes. Can I do it the other way for you? Can I do it with the coordinate pairs switched? So this would be m equals negative 3 subtract 1 over negative 5 subtract 2. Now remember the equation, the formula has a subtract signs in it. That's where I'm getting those from. And these ones are positive, so I don't need to use brackets around them. So I'm going to have a negative 4 divided by a negative 7. When you divide two negative numbers, what do you get? What's a negative divided by a negative? It's a positive. So we don't leave it like this in math. We don't leave a negative over a negative. We rewrite it as a positive. So it doesn't matter what coordinate pair you pick to be the first coordinate pair or the second. You can flip-flop them and you're going to get the exact same answer. So you and I can do it two different ways and we can get the exact same answer. Easier than exponents? Nice.
This is way more funner.
Funner? I like it.
That's not a word.
What?
Here, sit in English class.
Am I good to flip? Okay, perfect. All right. So what is the slope of the line that passes through these? Oh, my points ended up over here. See it? These points kind of got buried behind the picture. So if we were to connect these points, what's the slope of that line? So we have a pretty picture, and these points are kind of nice. So I'm going to look at this point to this point. Hey, is it going to be a positive slope or a negative slope?
Positive.
So you guys should anticipate a positive slope. Nice when you have the picture because you can know those things. So I'm going to look at my change in y first. over my change in x. So how high do I have to go to get to the next point? Maybe I'll use a different color there. So I was at 24, and I need to get to 48. So I've gone up 24. So up is a positive, right? And now I'm moving to the right. So I started at 1, and I'm going over to 2. So how far did I go over?
1.
1 unit. And I went to the right, so that's a positive. So what's the slope of this line?
24 kilometers per hour.
So the slope is a positive 24. So we know that up and right are positive, down and left are negative. Okay? What does the slope represent? Rahat?
24 kilometers per hour.
Okay, so you're telling me there is a unit on this. So kilometers are on the y, so that would be my numerator. What's my denominator? It's 1. We usually don't put it. So it's kilometers per hour. So kilometers per hour. What is measured in kilometers per hour? Speed.
Our is driving at 200 kilometers per hour.
So that's the speed that we're traveling at. Make sense? All right. Okay. How can the answer in part B be used to determine how far Yvonne traveled in 1 3/4 hours? Woo. We're going to do some ratios. We're going to do some ratios. Exciting stuff, I know. What was her speed? 24. So 24 per hour, right? Do you expect this answer to be more or less than 24?
More.
How come?
More, okay. So
No. How come? Condense your response.
Since it's more than 1 hour?
Because it's more than 1 hour. Good answer. So we know that we traveled 24 kilometers in 1 hour. Are we traveling more than 1 hour here? Yes, so we should be able to travel further. Everybody agree with that? Yes. So it's good to know if you can math it out. If you can math it out kind of to predict where you're going to be. All right, so we have the slope there, right? And we're going to set that equal to, I'm trying to find how far she went. Can we put this into a decimal for me?
No fraction.
No fractions.
6.
What?
Nothing.
Okay. How about this? Can we put 3/4 into a decimal for me? How would we convert 3/4 into a decimal? What does that line mean in between them? Division. So if we could take 3 and divide it by 4, what would we get?
0.75.
0.75 plus the one that we went, so that would be 1.75.
I knew it.
All right, so here's some mathy stuff for you. I want to figure out, I want to get question mark by itself. And so notice that I wrote the H here and the KM on the top. So I know that kilometers have to be on the top and hours have to be on the bottom. That's why I put hours in that location there. Okay, so this is a little bit of algebra. If this is divide by 175, what do I have to do to get rid of it? Multiply. Just going to lose that for a second. So I'm going to multiply this side by 175. What do I have to do to the other side? Also multiply it by 175. Of course. All right, grabbing my handy dandy calculator. Those cancel each other out, leaving me with just a question mark on this side. And I'm going to have 24 times 175 gives me 42 over 1.
Hours.
What? No. So what's 42 divided by 1? Should still be 42. So my question mark. Perfect. So the question is, and what level was my question mark on? Was it on the kilometer level or was it on the hour level in the fraction? It was on the top, so it was in kilometers. And the question asks how far. So we know that she can go 42 kilometers in 1 3/4 of an hour. Brilliant. Okay, using the same setup, can you do part 2? Yes, you can. Yes, you can. Start with your slope. Start with your slope. So the 24 is the distance, and the 1 is the time. So we're going to make a new fraction. And what information do we have? Do we have distance or do we have time? On the new fraction. Distance. And how much is our distance? Try again. 55. And what are we trying to find? We're trying to find the time. Solve for the question mark. How? How?
I got this.
You got this? This is trigonometry again, guys. Why would we ever do trigonometry? Okay, we did, not Miss Monroe, but that's okay. We did trigonometry last unit. Okay. You were here. Okay, so I'm going to get the question mark off the bottom. I'm going to times this side by question mark. I'm going to times this side by question mark. Right? Because you told me I have to multiply both sides by the same thing. So these question marks cancel each other out. I'm left with 24 times the question mark. I probably should have used a letter. What's 24 divided by 1? 24. Do I need to, can I get rid of that? So I want question mark by itself. What's happening between the 24 and the question mark if nothing's stated? Multiply. So how do I get rid of the 24 if they're multiplied? Divide by 24. Divide by 24. So question mark is equal to 55 divided by 24 is 2.29. And what are my units on this? What was I trying to find? Hours. Yeah, I was trying to find the time it took. So it would take her 2.29 hours to travel 55 kilometers.
This woman could go to Clean Lake and back.
True story, yeah. But we don't know how fit she is. Maybe this is her average speed, but maybe she'd be too tired after an hour and a quarter, right? Maybe she'd just be like, I need a break on the side of the road. We're going to assume she can continue on forever because Yvonne seems like she's going to be strong at that. Okay, that's it for today's lesson. So here's my advice. If you have not finished your exponent stuff,